Morning, everybody. Dr. Green here, and today we are moving on an intro to software engineering with building. Building is a really important piece of software development, and it gives us some really key things that we need to remember. One is all about reproducibility. The second is that all the code we write to build our software is real code and should be treated and such. And you should always remember that build should fit your project, not the other way around. So on to build tools. What are these things? These are tools that allow you to write instructions to deal with your own code. Okay? So long story short, version control is just not enough. We need to put the entire process of taking our code and turning it into a distributable project in an automated unit. Okay? We got to put all this together. That may even include testing and building and deployment, all kinds of different things. And answers questions like, which class is your main class? How should it be run? How do we do this? How do we distribute it? But the really important thing that a build tool gives us is reproducibility. Because you see, when we combine code with an environment with a build tool, we end up with reproducibility, right? We have the same code built in a similar environment, and we combine that with a build tool. So there are lots of tools that we have to do this, right? You can take a second, think about this. Can you name any yourself? I can name plenty. Make, MS Build, Xcode Build, Rake, Maven, Ant, CMake, Premake, QMake, Fabric, Grunt, Homebrew. These are all things, and there's a nice little blog article on this that you can read. And in this, there's even another tool now that I would include, and that's called Docker, which helps us maintain a stable environment across our builds. So there's lots and lots of options here, and I'll be showing you another video later that incorporates Docker and gives you a demonstration of this, so don't worry about that. Okay? So basically what build tools do is they do lots of stuff. They can generate documentation, they compile, they clean up the mess they make, and they do some crazy other things. They can reference libraries, run apps, generate documents again and again. They can even interact with version control. Okay, so they can do tons and tons of things. So today I'm going to go briefly over two of what I think are the more common and more easy to use build tools. The first is Make. You can go there, right? Their logo is a GNU, right? That is what it is. It's not a RAM. And basically what this is made to do is something like this. You've all seen C++, and we use the G++ compiler typically. So you may compile some CPP code and give it an output into hello. But wouldn't it be nice if we could just type make all? Okay? I have some much more complicated projects than that I'll demonstrate for you later. But being able to type make all eases our burden tremendously. So the way make works is that you build a make file. Literally, the file is named makefile, all lowercase. And it has this type of format to it. Target : dependencies, right? So the target is something like all. Dependencies are what that target depends on. The next line starts with a tab, and then you enter system commands. Make files only work with tabs, by the way. So if you're like me and you know that spaces are the best choice for formatting your code, when it comes to the Make ecosystem, you are incorrect and must switch to tabs. So an example of this looks just like this. You have an all, and then you just type in that code. Now all I would have to do in that directory is type make all. But there is a small problem, right? Mostly that things are more complicated than this, that they have dependencies, that they have all this kind of stuff. So what we want to do is beef this up, something like this, where we have multiple targets, right? So we have the target all. All depends on hello. Hello depends on multiple object files or intermediate files you can generate. And the command we want to run is G++ with all of those with the output. Okay? But main.o depends on main.cpp, which is created that way. That -c means generate the .o file. Factorial.o, you see all these go this way. And then we even add a make clean command, which is a best practice, which removes all the intermediate files and garbage. So this is a basic make file to compile a basic project. You can do some things with wildcards and stuff in there, which we'll talk about in a second. So if I want to amp this up a notch, I can do something like this. I can actually use make variables. You'll see the cc equals G++ on line 3. That means create a variable named cc and store G++ in there. I can add flags, right? C flags is very common to see. -C and -wall, right? That means, as far as warnings go, include all of them. And what I can do is then I can use those variables down in what I've done. So you've seen in the on line 11 and 12, we will reference CC, and we do that by using a $ left paren CC right paren. That says use the output of whatever is in my CC variable. We do the same with C flags. We can go through this. This is really nice, and we also have comments in there. Pretty sweet. Okay? We can also step this up another notch. Right? We can go in here and we can say something like this. CC is the common command for our compiler, will be G++, C flags there. LD flags would be our library or linker flags. We can actually list out sources, all the files that are our sources. You can see there on line 4, I say sources equals main.cpp, hello.cpp, and factorial.cpp. I can then create objects, and I've done a little fancy thing here on line 5, and what that is I've taken all the text in the sources variable and replaced .cpp with .o, right? So that command there means take sources, replace all occurrences of .cpp with .o. And then I've even added a variable called my executable. Some people will call this a target when you see it in a makefile. And then I can go down and I can include these in my things. But check this out. Now I can make all my rules super condensed and super not easy to read, but really sweet because it's very efficient, right? Because all depends on my sources and executable. And now on line 10, my executable depends on my objects. And I compile that executable by using my CC with LD flags and objects. And then I have this really weird -o $at, which we'll get to. And then I have this other dependencies, right, which says I can build this another way. You see, in Make, we have all these variables that we can look at, right? So $at, the file name of the target, $left caret, the name of the first prereq, $up, the names of all the prerequisites or dependencies, $*D, all this kind of stuff, which is just really crazy. Great part about this is it's super terse. It's clearly developed by programmers and developers for programmers and developers. It's super efficient. It runs really well. The downside is it completely burns your eyes out, and you have to get a lot in your head to make it work in a really awesome way. The good news is you can write most of this out in plain text. You don't have to use the variables, but they are shortcuts. Another example here is something really simple that runs multiple commands. You have my paper, right, which is something called LaTeX, and that depends on some figures. And, we put all this stuff in here. And you'll see the beginning looks really plain, but then on line 9 and 10, we have this crazy CD $left D, the directory part of the first prerequisite. R command, right? So all this kind of stuff that we can do and go crazy with and make it rock. So there's lots of options with Make. It's very common. It's very widely used. Good things, it's everywhere. It's powerful, and it catches changes and rebuilds automatically. So Make has this nice feature where it only updates what it needs to update. It won't recompile everything in large projects, so it can save you time. Disadvantages is that it gives you ugly, terrible, no good, very bad syntax. I hate writing Make files because I often hate the syntax. You can only use tabs, no spaces. And it doesn't work well with recursion, even though you can do recursion by having one makefile per directory and recursively calling those, and the whole thing gets messy. It also has limited support of sort of if-else statements and if-then, which can cause problems. I have a bunch of resources here for you. You can check these out. You can click on them. You can go through. They're on a page in Canvas as well. Now, as opposed to Make, we have a more modern tool called RAKE, right? Which is basically using Ruby to write a build file. So here we have a task we've created. That task is named default. You'll see that colon just means this is a special variable called, that gives us a name. For the task default, do puts hello world. That means print in Ruby, and it'll put it out hello world. You can even deal with dependencies, right? So task enter, colon enter, depends on the task ring. So if I said, rake enter, it would also ring the doorbell, right? Or I can write that dependency elsewhere. So I can write multiple tasks like ring and enter, and then I can write the dependency outwhere. The really cool thing about RAKE is that this is literally just straight up Ruby code. So if you know Ruby, it's really easy to use. You can jump in, and I also have some really good resources here. Now I'm going to compare these two for you. In Make, you'd end up with something like this, @echo hello world. In RAKE, you'd have task hello do puts hello world end. Okay, so this isn't terrible. This really isn't bad. They're similar in a lot of ways. They're a little different. The syntax is different, but generally not that different. Here's a more technical one, right? So in Rake, we do something like file target is this, do, and run sh update the file name with all the prerequisites joined. Whereas in make, we could simply say my target depends on prereq 1, 2, 3, and 4, and we run the command update, right, with the appropriate shortcuts to the variable names. Here, make is rather unreadable. Rake is much more readable. Make is much shorter. Rake is much longer. Okay, so we're starting to see trade-offs here. Make is very powerful, but it's very terse and can be difficult to read. Rake is also very powerful, but it can be much more verbose and make you write more code, even though it's more explicit and potentially easier to understand. Here's another one. We have a default task called hello with a source and object list. We have a rule for translating .o to .c. We have a file hello object, right, that compiles, and we have some dependencies. Main.o depends on this. And that goes down to a very simple make file, something that we've sort of talked about before, right? The new things you'll see in there are that wildcard command, which is just get everything with *.c. You'll see some of the shortcuts we reference later. So this is just a comparison, so you can see the difference in a couple build tools. Now let me be really clear, make and rake are not the only two tools out there. For all I care and for all your team does, you can write your make tool in C++. I think that's a bad idea. I think build files and build tools should typically be written using a scripting language like Ruby or Python or the make file. But that's up to you. But I want you to notice here above all that no matter what you do, the tool that builds your code is just more code. So always remember to treat it as such as well, okay? Whatever build tool you have, whatever build scripts, whatever make files, they need to be integrated within your code. They need to be put in directories and version controlled and all that kind of stuff because you'll update them just like real tool. Now, your book talks about a tool called Ant, which is another neat tool. It's typically used with Java. And it's sort of complicated. Okay? You build these long build scripts that are based on XML. Right? So you'd have a build script that has a project name, that has properties, that has targets, and that has tasks. Some of you may really like this. I really don't. So I'm going to avoid it out. I really hate XML. It's hard to work with. It gets really clunky. I prefer scripting. So the last thing I want you to know is 100%, don't forget, the best build tool is the one you write yourself. Whether it's Rake or Make or C++ or Python or whatever it is. The tool that works best for your team is the tool that's best for you. And don't dare be afraid of this. Build should fit your project, not the other way around. Don't just stuff your project into a build tool. Right? Pick a build tool that fits your team, that fits your project. For C++, I would really recommend Make or Ruby. For Java, most likely you're going to use Ant or Maven. This goes on, but use what's appropriate. Even if you use Visual Studio Code, right, all the build tools are built in there, and you can see the scripts they generate, but the MS build tool is built in there. So the bottom line is, remember that build tools can do a lot of things. They do all the extra stuff that makes your code into a real product in a reproducible environment. They can do lots of stuff for you. You should always pick the best tool to fit your team and your project. And these build tools are real code, so they should be treated as such and kept inside your code base with your repository and be updated and version controlled and all those things. So that should do it for build tools. There'll be a couple other videos with some small demonstrations, and I hope you all have a great week.